Most weeks, we pick one concept and go deep on it. This week is a bit different. I'd venture to guess most of you listening have toyed around with connecting your e-commerce store to Claude. The pitch behind connecting Claude to your store goes like this. Give the model access to your data, and it will tell you what's happening in your business. If you've tried it, you already know it doesn't quite work that way. And the reason isn't access to your data, it's the structure of it. Hi, I'm Alex Orley, and this is Hard Margins, your weekly e-commerce brief brought to you by RetentionX. RetentionX closes the loop from identity to insight to agentic execution, helping commerce brands understand customer value, identify growth opportunities, and execute against those opportunities through intelligent workflows and agents. If you have questions or topics you'd like covered, reach out directly, alex@hardmargins.com. This week, we're talking about RetentionX's just launched Claude MCP, what it is, why a raw data connection often falls short, and 6 pre-built workflows that show what a structured commerce layer actually can make possible. Most of you have probably tried the Access version of this. You connected Shopify to Claude, maybe Klaviyo too, asked a real question. Which products are compounding repeat purchases? Why is payback slipping? And got something that looked like an answer. But on closer inspection, you realize it's generic and some of the numbers are likely wrong. That's not necessarily a Claude problem, it's a data layer problem. And it's the reason the next phase of commerce tooling won't be about connecting models to more data. It'll be about connecting them to data that's already been made meaningful. Most MCPs, including Shopify's, simply expose your raw data, orders, customers, line items. To answer a question like, are May cohorts worse than April? Claude has to assemble that cohort from millions of rows of raw data. It can't do that reliably. It samples, joins, and fills the gaps from training data. That's where the wrong numbers come from. And it's the same gap that explains why those connections never answer the second layer questions. Which channel, which product, which discount depth? No raw schema exposes those dimensions pre-built. The RetentionX MCP is not a connection to your store's database. It's a connection to a commerce intelligence layer, one where cohort retention curves, follow-up purchase rates by product, replenishment timing, LTV horizons, payback windows, and segment-level contribution margin are already computed, already structured, and ready for Claude to read directly. That changes 2 things at once. First, it changes depth. Because every dimension is pre-computed, the second question is essentially already available. You don't just ask what your retention looks like, you ask it by acquisition product for meta-acquired customers last quarter against baseline. 4 pivots in that question without changing tools. That's where connections between variables, anomalies, and root causes start surfacing in ways they never could from a raw data set. The second is trust. Structured answers mean Claude isn't guessing what LTV 90 means or estimating follow-up rates from a sample. It's reading a number out of a defined contract. If the layer doesn't have something, it says so. It doesn't invent it. That distinction matters when you're making actual resource allocation decisions based on the output. RetentionX has built 6 skills on top of their MCP, pre-structured workflows that make Claude useful from the first question, rather than leaving you to figure out what to ask and why. I'm going to walk you through what each one does. The first is the cohort check. The question it answers is, are this month's customers worse than baseline? It produces a retention curve overlay, an LTV horizon, and a repeat survival analysis with the exact divergence point named. You see the problem before it shows up in revenue. Second is the anomaly scan, which answers the question you probably didn't even know to ask. What should I be paying attention to right now? It surfaces 5 findings ranked by revenue impact, each tagged as a silent leak, a positive surprise, or a structural issue, each one defined with a 1-line next move attached. Third is product stickiness. Which SKUs are ritual heroes and which are replaceable? If you've listened to multiple episodes of this podcast, you've heard me talk about this a lot. It outputs a 2x2 of brand stickiness versus product stickiness with a protect and scale list, essentially a merchandising audit condensed right into a single output. I love this one. Fourth is the revenue forecast. Where are we going to land and why? We provide a bear, base, and bull projection with named drivers and specific signals to watch over the coming days. Event aware, not a linear extrapolation through peaks. Fifth is segment insights. Which customer segments behave structurally differently from each other? The aggregate view often hides this. The scan finds it, including cross-promotion callouts when two segments are rotating through different parts of the catalog in ways that will matter to you. Sixth is category performance. Which categories are healthy and which are on watch? A 6-dimension, tiered scorecard with a loyalty by margin scatter. The kind of analysis that used to take multiple weeks of prep, available with the click of a button. The dashboard era was about making humans interpret data. The raw MCP era was about making models assemble it. What comes next is a structured commerce layer the model reads and the operator asks. RetentionX is providing 6 skills to start. Every question you bring from there is one query away. They're also offering a 30-day free trial, including all Claude MCP functionality. Simply go to RetentionX.com and check it out. Thanks for listening. I'm Alex Orley. This has been Hard Margins, brought to you by RetentionX. If you have questions or topics you'd like covered, reach out, alex@hardmargins.com. I'd love to hear from you. I'll see you right here next week for our regularly scheduled programming.